Hello, and welcome to this lightning talk on lazy loading container images on AWS Fargate with Seekable OCI. My name is Ollie Pomeroy, and I'm a Senior Developer Advocate here at AWS. AWS Fargate is a serverless compute engine for containers. Fargate removes the undifferentiated heavy lifting of maintaining AMIs and managing the underlying Amazon EC2 instances. And Fargate secures the underlying infrastructure to run your workloads because every container is ran on a single-use, single-tenant EC2 instance. With AWS Fargate, you only pay for what you use, and you're billed by the second. When customers started adopting containers, people traditionally used them for microservices or API and web-based workloads. But since then, we've seen an explosion in the use cases that people use containers for. And in the past year or two on AWS Fargate, we have seen customers use things like CPU-based machine learning training, batch and parallel processing, and data processing pipeline workloads on AWS Fargate. With these new workload types, we have seen an increase in the size of the container images that people are attempting to run. And on AWS Fargate, the size of the container image is directly proportional to the time it takes to start your workload. And that's because we have to download your container image every single time because it is a single-use and single-tenant piece of EC2 infrastructure. On behalf of our customers, we have been looking at ways to reduce the time taken to launch Fargate tasks. And this led us on to lazy loading. Now, lazy loading is technology that's traditionally used in web development. And here, all of the data of a website wouldn't be downloaded up front, instead would be downloaded when the user requests it. Translating that to container images, what we're able to do is we're able to start a container almost instantaneously. And then when the application requests a particular file or binary, we go and retrieve it from the container repository. At the end of 2022, AWS announced a new open source project called Seekable OCI, or SOCI for short. And Seekable OCI is the underlying technology that enables lazy loading. It provides the capability for us to extract a subset of an existing container image while it is stored inside of the repository. It's able to do this because you create a SOCI index of your container image. The SOCI index is a metadata file that tells us exactly which files are in your container image and where within that container image they are stored. We are able to generate a SOCI index without modifying that existing container image so your security supply chain remains intact. SOCI stores that index alongside of the container image in the container repository. There are no changes to the application code or the container image or even the ECS task definition to use Seekable OCI. Once you've created that SOCI index, AWS Fargate will detect it in the container repository. If it exists, Fargate will lazy load your container image, reducing your launch time. If the index does not exist, AWS Fargate will fail back and download your container image in full, as it has done before. SOCI is available on AWS Fargate at no additional cost and is available for Linux tasks on platform version 1.4 or newer. Let's start the demonstration in the Amazon ECS console. Here you can see that I have no running workloads. There are no tasks currently in my cluster. I have, however, created two task definitions. A task definition in Amazon ECS is how we define our workloads. Here I have defined my containers, the container images, and various runtime parameters. I have created two task definitions, one called PyTorch Training and a second called PyTorch Training No Index. If we explore the raw file of that first task definition, you can see that I have defined a single container. That container is called PyTorch Training, and it is using a container image that I have defined and stored in my Amazon ECR repository. Outside of that, you can see some entry point commands and some logging configuration has been defined. If you look in the second task definition, here you'll notice it's labeled no index. It is almost identical. The same runtime parameters, the same single container image, but a slightly different container image name. The first task definition is pulling from a repository called PyTorch Training. Here you can see I have a container image called latest, as well as a SOCI index. A SOCI index is our metadata file that we can use to find individual files within our container image. We also have a second metadata file that Fargate uses to identify which index to use. In my second ECR repository that I'm using in the second task definition, I just have the container image. There are no SOCI artifacts here, but the container image is identical to the last one. Next, I'm going to start a number of tasks on my Amazon ECS cluster. And I'm going to do so using the run task command. I'm going to launch two different commands, each starting two ECS tasks. These tasks will use the launch type Fargate, and below you can see the task definitions I have used. So there'll be two tasks from the first task definition, there'll be two tasks from the second task definition. Outside of that, I have defined my cluster and the VPC configuration. I'll now execute that bash script, starting the four tasks on my cluster. A quick check back in the Amazon ECS console and a refresh of the page, we should now have our four tasks provisioning. This is the first state of a task lifecycle. You can see that I have my four tasks, two from each task definition. Quick refresh of that page has shown that tasks from the first task definition, PyTorch Training, have started almost instantly. We haven't waited for a large multi-gigabyte container image to be downloaded before we've moved those tasks into the running state. If you refresh again, you'll see that the PyTorch Training No Index tasks have finally started. These had to wait because we had to download the container image in full. They were not using SOCI and therefore they were not lazy loaded. Here, remember, I have not modified my container image or my application in any way. I've just generated a SOCI index. Thank you.